Welcome to Junk Drawer Facts, the place where curiosity lives in the everyday. In this video, you'll find a continuous stream of wholesome and fascinating facts covering everything from nature and science to food, geography, language, design, and the small details that make our world so interesting. Whether you're listening in the background, winding down after a long day, or just looking to learn something new, thank you for choosing to spend your time here. Now, let's open the junk drawer and see what interesting facts we discover today. A fun place to start this drawer is with 0, because 0 is not just a symbol for nothing. It is a placeholder that lets every digit know exactly where it belongs. In a place value system, the same digit can mean 5, 50, or 5,000 depending on its seat in the number, which is a surprisingly elegant bit of organization. That organization is why 100 can be written with one little one and two little zeros instead of needing a brand new mark for every quantity people want to count. Once numbers can hold places, calculation becomes much easier to teach, copy, and check, and that leads us straight to the humble abacus. An abacus does not solve a problem by magic. It simply gives each place value its own row or column of beads, turning invisible arithmetic into a little moving picture. The idea is so clear that many people can perform fast calculations on an abacus and then keep the same bead layout in their imagination after the physical frame is gone. From beads, it is a short hop to tally marks, which work because groups of 5 are easy for the eye to scan. 4 straight marks, followed by a 5th crossing mark, turns loose, counting into tidy bundles, and tidy bundles are the secret behind a lot of everyday math. The same urge to bundle shows up in dozens because 12 divides neatly by 2, 3, 4, and 6. That divisibility is one reason dozens have been handy for trade, packaging, and mental math long after calculators became ordinary. 60 is even more flexible, and that helps explain why minutes and seconds are grouped in 60s rather than hundreds. A circle also gets divided into 360 degrees, a number with many divisors, which makes it convenient for sharing angles into equal slices. When people measure time or angles, they are often choosing numbers that are friendly to divide, not just numbers that look round in decimal form. Decimal form is still wonderfully useful though, because powers of 10 match the way most of us write numbers. Move a decimal point one place and the value changes by a factor of 10. Move it 2 places and the value changes by a factor of 100. That simple sliding trick is one reason metric prefixes feel so orderly once they click. Milli means 1,000th, centi means 100th, kilo means 1,000, and the same prefixes can travel from meters to grams to liters without learning a new counting system each time. A liter is the volume of a cube 10 centimeters on each side, which makes capacity connect neatly to length. The metric system likes those clean relationships, and the modern kilogram is defined through a fixed value of Planck's constant, so the standard is tied to a property of physics rather than a single object in a vault. Measurement has a long memory, but it also keeps updating itself when a better anchor comes along. Paper sizes have their own elegant anchor too, because the A series uses a rectangle whose sides keep the same ratio when the sheet is folded in half. Fold an A4 sheet across its longer side, and the smaller sheet keeps the same shape as the original. It is just scaled down. That makes resizing documents much less fussy because the proportions stay consistent from poster size to notebook size. Proportion is also why a square is such a satisfying shape for puzzles, tiles, and grids. A square has 4 equal sides, 4 right angles, and a neat kind of symmetry that makes it easy to rotate without looking unfamiliar. A cube takes that square into 3 dimensions, giving 6 equal faces and a tidy way to picture volume. Once you start seeing dimensions as steps, a line is one-dimensional, a square is 2-dimensional, and a cube is 3-dimensional, which makes geometry feel like a ladder rather than a wall. A triangle brings its own charm because it is rigid. If the side lengths are fixed, its shape cannot wobble into a different form the way a 4-sided frame can. That is why triangles show up in structures, patterns, and folded supports whenever stability matters. In Numberland, triangles appear again as triangular numbers: 1, 3, 6, 10, 15, and so on. Each triangular number is what you get when dots can be arranged into a neat triangle, adding one longer row each time. Square numbers do the same thing with squares, and cube numbers do it with cubes, turning arithmetic into little stacks you can picture. Prime numbers are different. They resist being arranged into a rectangle with more than one row unless one side is just 1. That makes primes feel like the building blocks of multiplication because every whole number can be broken down into primes in one unique way. Some numbers are special because of shape, and some are special because of sound or symmetry. A palindrome number, like 1251, reads the same forward and backward, which gives it a tiny mirror tucked inside. A repeating decimal, like 1/3 written as 0, 333, shows that not every clean fraction becomes a short decimal. On the other hand, 1/8 becomes 0, 125, because eighths fit neatly into thousandths. Fractions and decimals are not rivals. They are two outfits for the same value, and each outfit is better for different moments. Percentages are another outfit, and percent literally means per hundred in the mathematical sense of the idea. If something increases by 10%, it rises by 10 for every 100 of the starting amount, which is why percentages are easiest when you keep the starting point in view. Ratios do similar work without locking everything to 100. A recipe of 2 parts to 1 part can be scaled up or down, and the relationship stays the same even when the container changes. Scaling is really the quiet hero of maps, models, patterns, and diagrams, though today we can keep the focus on the math and not the place. A scale model is not just smaller. Every matching length has been reduced by the same factor. That is what keeps the model honest. Logarithms take scaling into a stranger but useful direction because they turn multiplication into addition. Before electronic calculators, slide rules used logarithmic scales so that lining up distances could help people multiply and divide. A slide rule is basically a ruler that lets numbers talk through spacing instead of through columns of written work. That idea leads nicely to binary, where spacing is replaced by place values of 2. In binary, the number written as 10 means 2 because the second place is the 2's place. Add another place and 100 means 4, then 1000 means 8. And computers can build huge amounts of information from long strings of those two choices. The same yes or no simplicity is why check digits are so useful. A check digit is an extra digit calculated from the others. And if one digit gets copied incorrectly, the check can often reveal that something is off. Barcodes and identification numbers use related ideas so machines can catch small mistakes quickly. Calendars catch a different kind of mismatch: the fact that a year does not contain a perfectly even number of days. The Gregorian calendar handles this with leap years, adding an extra day in years divisible by 4, except most century years, unless the year is also divisible by 400. That sounds fussy, but it keeps the calendar lined up surprisingly well over long stretches. Weeks are tidier because they simply repeat every 7 days, creating a rhythm people can follow without needing to know the month length. Months are less even, and that unevenness is why the little knuckle trick for remembering month lengths has survived so well. Raised knuckles are the longer months, and the spaces between them are the shorter ones, with February handled as the special case. Time zones add another layer of coordination, and they make noon a shared clock idea rather than a perfect match for the sun at every single address. A clock face turns time into a circle, and every hour mark on a 12-hour clock is 30 degrees from the next one. The minute hand makes a full turn every hour, while the hour hand moves slowly along with it, which means the two hands almost never point exactly where intuition first expects. Analog clocks are small geometry lessons hiding in plain sight. Digital clocks trade the circle for place value, and that brings the story back to zeros again. Leading zeros, like the 0 in 0705, do not change the amount of time, but they keep the format aligned so every time stamp has the same shape. That is why the international date style of year, month, and day sorts so neatly on a computer. The largest unit comes first. Then the smaller units follow. Sorting is a math idea, wearing an office outfit. Alphabetical lists, numbered labels, color codes, and file names all depend on consistent rules that let small pieces fall into a predictable order. Patterns are comforting because they lower the amount of guessing we have to do. Even random numbers can be tested for patterns because true randomness has a texture of its own, including streaks that can look suspicious even when nothing unusual is happening. A shuffled playlist can play two songs by the same artist close together simply because randomness does not promise perfect spacing. People often expect random things to look evenly mixed, but even mixing is usually a pattern too. Probability is full of these gentle surprises. Flip a fair coin 5 times and you might get 5 heads, which feels dramatic but is one of many possible sequences. The chance of a specific 5-flip sequence is the same whether it looks messy or neat. That is a lovely reminder that math does not always match our first feeling, but it can explain the feeling once we slow down. Color feels simple until you remember it is really a conversation among light, surfaces, and eyes. A red object is not storing redness like paint in a bucket. It is reflecting certain wavelengths of light and absorbing others, while your eyes and brain turn that signal into the color experience you know. That means color is partly out in the world and partly built inside perception, which is why the same sweater can look a little different under a kitchen bulb, a shop light, and bright daylight through a window. That effect has a name: metamerism, and it happens when two colors appear to match under one light source but separate under another. Paint stores, fabric counters, and printers all care about metamerism because a perfect match in one room may become a polite disagreement in another. Light bulbs add their own personality through color temperature, measured in kelvins. A lower Kelvin number usually looks warmer and more golden, while a higher Kelvin number looks cooler and more bluish, which is delightfully backwards if you are thinking about ordinary temperature instead of light appearance. Screens create color in yet another way, using red, green, and blue light together. Add those 3 colors of light at full strength and you get white, so screen color is called additive color. Printing usually works the opposite way because ink and toner absorb light from a white surface, so cyan, magenta, yellow, and black are used in a subtractive color system. The black ink is not just there because printers are dramatic, it helps make text crisp, shadows rich, and printing more efficient. A printed dot can be so tiny that your eye blends it with neighboring dots, which is how a magazine image can look smooth even when it is built from many little marks. That little blending trick is related to halftoning, where different dot sizes or dot spacing create the appearance of lighter and darker tones. Step close to certain printed pictures and you see dots. Step back and the dots become shading. Screens do something similar with pixels, but each pixel often contains smaller red, green, and blue subpixels. When those subpixels shine at different strengths, they mix into the colors your eyes read as a single point. This is why a screen can show a bright yellow even though there may not be a yellow light inside each pixel. Red and green light together can produce that yellow sensation. Magenta is even more interesting because it does not correspond to a single wavelength in the visible spectrum. Your brain creates the magenta experience when red and blue signals arrive together without the green in between. In other words, magenta is a reminder that color is not just physics. It is perception doing a little creative bookkeeping. After images are another example. Stare at a strong color for a little while, then look at a blank surface, and you may see a ghostly opposite color because some visual receptors have adapted more than others. The effect fades quickly, but it shows that vision is active, flexible, and constantly adjusting. Your eyes are also better at noticing some differences than others. Human vision is especially sensitive to greenish light, which is one reason night vision displays and some high visibility signs lean into that part of perception. But visibility is not only about hue, contrast matters enormously. A pale yellow word on a white background can be hard to read, while the same word on a dark background pops into focus. Designers use contrast to guide attention, and that is why warning labels, road signs, app buttons, and museum captions all depend on careful color pairing. Color accessibility adds another thoughtful layer because not everyone separates reds and greens or blues and yellows in the same way. A chart that relies only on color can become confusing, but a chart that also uses labels, shapes, or patterns can welcome more readers. Patterns are a nice bridge to moire effects, those shimmering ripples that appear when two grids or stripes overlap at slightly different angles. Moire patterns can show up on camera when fabric, screens, or fine lines interfere with the sensor grid. The pattern is not actually printed as a wavy design. It appears from the interaction between two regular structures. Thin film interference works in a more delicate way. A very thin layer can reflect light from its top and bottom surfaces, and the tiny difference in travel distance can make certain colors strengthen while others soften. That is the principle behind many pearly, iridescent, and color-shifting effects. A soap bubble is the classic example. But since this drawer is staying in a fresh lane, imagine instead a delicate decorative coating that changes as you tilt it under a lamp. Tilt changes the path of the light and the color seems to move. Polarized light adds another layer of hidden order. Ordinary light can vibrate in many directions, while polarized light is filtered so more of it vibrates in a particular direction. Polarized sunglasses reduce certain glare because light reflecting from flat surfaces often becomes partially polarized. That is why a shiny reflection can calm down when you turn the glasses at the right angle. Camera filters can use the same idea to deepen skies, tame reflections, or reveal details behind glass. Glass itself is a quiet color story because clear glass can have a faint green edge from small amounts of iron in the material. Look at a thick glass tabletop from the side and you may notice the tint gathering at the edge even when the top surface seems clear. Museum and display glass often uses special coatings to reduce reflections, making the object behind it feel closer and easier to see. Anti-reflective coatings work by managing how light bounces from a surface, sometimes using interference to cancel part of the reflection. That sounds fancy, but the goal is very simple. More looking, less glare. Lenses use curved glass or plastic to bend light, and the exact curve controls how the light focuses. A magnifying glass makes nearby details look larger because it changes the angle of the light entering your eye. A prism separates colors because different wavelengths bend by slightly different amounts as they pass through the material. That separation is called dispersion, and it is a beautiful reminder that white light can be a bundle of many color signals traveling together. Cameras borrow from the eye, but add mechanical control. An aperture is an adjustable opening that controls how much light reaches the sensor or film. A wider aperture lets in more light and can soften the background, while a smaller aperture lets in less light and can keep more of a scene looking sharp. Shutter speed controls how long the sensor gathers light, which is why a quick exposure can freeze motion and a slower one can blur movement into a streak. ISO controls sensitivity in digital cameras, though higher sensitivity can add grainy noise. Photography is full of trade-offs, and color is one of the most charming ones. White balance tells a camera what should count as neutral under a particular light, so a white page does not turn orange under a warm bulb or blue in cool shade. Our eyes do a version of white balance automatically, which is why a familiar white mug usually still feels white even when the room lighting changes. That ability is called color constancy, and it helps the world feel stable. Optical illusions often play with that stability. The same grey square can look lighter or darker depending on the colors around it, because the brain judges surfaces in context rather than measuring them like a tiny laboratory. Context is why a paint swatch can look elegant on a card and surprising on a whole wall. More surface area means more reflected light, and nearby colors can nudge the way a hue feels. Gloss changes perception too. A glossy finish reflects sharper highlights, while a matte finish scatters light more softly. Satin and eggshell finishes live in the middle, offering a bit of glow without a mirror-like shine. Texture makes color feel deeper because tiny ridges and valleys create micro shadows. That is why the same color can look different on smooth paper, woven fabric, brushed metal, and textured plaster. Pigments bring history and chemistry into the drawer without needing anything heavy. Ultramarine was once prized because of the mineral source used to make it, while modern synthetic pigments made many vivid colors more affordable and consistent. Titanium dioxide became important for bright white paints because it scatters light strongly and covers surfaces well. Carbon black is made of very fine carbon particles and can produce deep, strong blacks in inks, paints, and plastics. Fluorescent colors seem extra bright because they can absorb light at one wavelength and emit it at another, adding a glow-like punch to ordinary reflected color. Phosphorescent materials go a step further by continuing to emit light for a while after the light source is removed. Glow-in-the-dark stickers feel playful, but they are also tiny demonstrations of stored energy being released as visible light. Color names can be wonderfully slippery. Teal sits between blue and green, coral sits between orange and pink, and greige lives in the cozy borderland between grey and beige. The boundaries are not always exact because color words are practical categories, not rigid boxes. That is why two people can look at the same swatch and one says sage while the other says olive. Neither person has to be wrong. They may simply be drawing the border in a slightly different place. Digital color tries to tame that slipperiness with codes. A hex color code uses 6 characters to describe the red, green, and blue values of a color on a screen. And with that, this block closes on a balanced, charming, cheerful, colorful, buoyant, delightful note, ready for the next fact. A good puzzle fact feels like a tiny door opening, so let this block begin with the jigsaw puzzle. Early jigsaw puzzles were often cut from thin wood, and the name comes from the saws later used to cut the shapes, even though many modern puzzles are stamped from cardboard with a shaped cutter. The pieces are called interlocking because their knobs and holes help each piece hold hands with its neighbors, and that little grip is what turns a pile of shapes into a single picture. The edge pieces feel easier because they carry one straight side, giving the solver a frame before the middle gets busy. That frame-first habit is really a strategy lesson. When a problem feels scattered, start by finding the boundary. Boundaries matter in mazes too. A maze has paths and choices, while a labyrinth traditionally has one winding route to the center and back out again. In a maze, you make decisions. In a labyrinth, you follow a path. That difference makes mazes feel like puzzles and labyrinths feel more like patterns. One classic maze-solving method is to keep one hand on the same wall, which works for certain mazes because it eventually traces a connected boundary. It does not solve every possible maze layout, but it is a wonderfully simple rule for a surprisingly twisty problem. Simple rules are the soul of Sudoku as well. A standard Sudoku grid has 9 rows, 9 columns, and 9 3x3 boxes, and the goal is to place the digits 1 through 9 so each group contains every digit once. The puzzle uses numbers, but it is really about logic, not arithmetic, because you are arranging symbols rather than calculating totals. A 3x3 magic square does use totals, and its classic version places the numbers 1 through 9 so every row, column, and diagonal sums to 15. The center is 5, which acts like the balancing point for the entire square. Balance shows up again in tangrams, the 7-piece dissection puzzle that can form silhouettes by rearranging simple geometric pieces. A tangram set has 5 triangles, 1 square, and 1 parallelogram. And the magic is that the same small family of shapes can suggest animals, people, letters, furniture, and abstract designs without adding a single extra piece. Since this script is keeping things gentle, think of the tangram as a shape-shifting paper theater. Another paper theater is origami, where folding changes a flat sheet into a structured form without cutting or glue. The valley fold dips away from you while the mountain fold rises toward you, and those two moves can combine into remarkably complex designs. Origami is not just decorative. The math of folding helps engineers think about compact structures, deployable panels, and efficient packaging. The Miura fold, for example, lets a sheet open and close in a smooth repeating pattern, almost like a paper accordion with a plan. Accordion folds led nicely to pop-up cards. A pop-up card works because carefully placed cuts, tabs, and folds turn the opening motion of the card into vertical movement. The delight comes from stored geometry waking up as the page opens. Mechanical puzzle boxes use the same kind of delight in 3 dimensions. A puzzle box may require sliding, pressing, tilting, or aligning parts in a specific order, and the best ones make the solution feel surprising but fair. Fairness is important in puzzles because the solver wants to feel challenged, not tricked by missing information. That is why good crosswords use clues that point somewhere specific, even when the clue is playful. The first modern newspaper crossword appeared in the early 20th century, and the form quickly became popular because it combines vocabulary, pattern recognition, and the satisfying click of crossing answers, confirming each other. A crossword grid is a social little structure. One answer helps its neighbors. Word searches are gentler cousins, hiding words in rows of letters that can run forward, backward, sideways, or diagonally, depending on the puzzle rules. The pleasure is visual scanning, and the moment a word pops out can feel like seeing a familiar face in a crowd of letters. Acrostic puzzles add another layer because selected letters from solved clues reveal a quotation or message. The puzzle becomes both a set of little answers and one larger hidden thread. Nonograms do something similar with pictures. In a nonogram, numbers beside the rows and columns describe runs of filled squares, and solving the clues gradually reveals an image. It feels like coloring by logic. A sliding tile puzzle is logic with motion. The classic 15 puzzle has numbered tiles in a 4x4 frame with one empty space, and the solver slides tiles around until the order is restored. The empty space is not a missing piece. It is the engine that allows movement. The Tower of Hanoi uses movement in a more elegant rhythm. With 3 pegs and a stack of discs, the rule is that a larger disc may never rest on a smaller disc, and the minimum number of moves for n discs is 2 to the n power minus 1. That formula grows quickly, which is why a puzzle that looks simple can become wonderfully patient. Patience is also the quiet teacher inside a Rubik's Cube. The cube was invented by Erno Rubik in the 1970s as a way to explore 3-dimensional movement, and the surprise was that twisting the cube scrambled it into a deep puzzle. A standard cube has 6 faces, each made of 9 stickers or colored tiles, but the important pieces are corners and edges that move in connected ways. Speed solvers do not rely on luck. They learn sequences of moves, called algorithms, that rearrange certain pieces while preserving others. An algorithm is just a repeatable recipe, which makes the cube a colorful lesson in procedure. Procedure also powers the Etch-a-Sketch. Inside the toy, a stylus scrapes aluminum powder from the inside of the screen, and the 2 knobs move the stylus horizontally and vertically. Turning both knobs together creates diagonal or curved-looking lines through coordinated motion. Shake the toy, and the powder recoats the screen so the drawing can start again. That reset is part of the charm. The spirograph creates charm through gears. A pen placed in a hole of a small gear rolls around another gear or ring, and the repeated motion traces looping curves called hypertrochoids or epitrochoids depending on the setup. The names are fancy, but the result feels like a flower drawn by mathematics. A kaleidoscope uses reflection for a similar kind of repeatable wonder. Mirrors set at angles multiply small bits of color into symmetrical patterns, and a tiny turn creates a new arrangement. The invention is associated with David Brewster in the 19th century, and the name comes from ideas of beauty, form, and viewing, but you do not need the name to enjoy the little rotating pattern show. Symmetry is the reason the patterns feel satisfying. Humans notice symmetry quickly, which makes it useful in logos, tiles, puzzles, and decorative borders. A pattern with rotational symmetry can turn and still look the same after a certain angle. A pattern with reflection symmetry can fold across a line and match itself. A tessellation covers a surface with repeated shapes and no gaps, and squares, triangles, and hexagons do that especially neatly. Pentaminos make tessellation more puzzling. A pentamino is made from 5 equal squares joined edge to edge, and there are 12 free pentamino shapes if rotations and flips are considered the same. Those 12 shapes can pack rectangles in many ways, turning a small set of pieces into a big arrangement challenge. Polyominoes in general are shapes made from equal squares, and the name echoes domino, which uses 2 squares. Domino sets have their own tidy counting fact. A double 6 set contains 28 tiles covering every unordered pair from blank blank through 6-6. The tiles are simple, but they invite matching, sorting, and pattern play. Matching games work because memory likes anchors. In a face-down matching game, players remember both identity and location, building a mental map of the hidden cards. The game feels light, but it exercises attention in a very direct way. Memory also helps in Simon-style electronic games where a growing sequence of lights and tones must be repeated in order. The sequence length increases one step at a time, turning short-term memory into a little staircase. The yo-yo brings physics into the toy drawer. A yo-yo stores energy as it spins, and the string winding and unwinding changes the balance between motion up and down and spinning around the axle. Modern yo-yos often use ball bearings to let the yo-yo sleep at the end of the string, giving players time for tricks before it returns. A slinky shows a different kind of motion because a wave can travel through its coils. Stretch it gently and send a pulse from one end, and the coil makes motion visible in a way a straight string cannot. Springs, strings, gears, and folds all make hidden rules easier to see. Building bricks do the same thing for design. Interlocking plastic bricks depend on precise tolerances. The studs must grip firmly enough to hold, but not so tightly that a builder cannot pull the pieces apart. Bricks from different sets can connect because the underlying system stays consistent. That consistency is why a small brick can become a roof, a wheel arch, a robot foot, or a tiny chair depending on context. Context is the secret ingredient in almost every toy and puzzle. A wooden block is a tower piece in one moment, a pretend loaf in another, and a measuring unit in the next. A puzzle piece is nonsense alone but meaningful when its neighbors arrive. A clue is confusing until one crossing letter makes it glow. Textiles are full of quiet engineering, so this drawer can begin with the simplest woven idea. Warp threads run lengthwise on a loom, and weft threads pass over and under them from side to side. Once you know those 2 words, a piece of fabric becomes easier to read, almost like a tiny grid made soft. Plain weave is the basic over one under one pattern, and it creates fabric that looks balanced on both sides. Twill weave shifts the over and under pattern with each row, forming diagonal ribs that make fabrics like denim recognizable. Satin weave lets threads float over longer stretches before dipping under, which creates a smoother surface and a softer shine. Those 3 weave families can produce an enormous range of textures without changing the basic idea that threads are crossing in an organized way. Knitting is different because it is built from loops pulled through loops. That loop structure gives knitted fabric more stretch, which is why a t-shirt moves differently from a crisp woven shirt. Rib knit alternates raised and recessed columns, making cuffs and collars springy enough to hug without needing complicated hardware. The stretch in fabric can come from structure, fiber, or added elastic, and each kind of stretch behaves a little differently. Bias stretch is especially interesting because woven fabric stretches more along the diagonal than along the straight grain. Cut fabric on the bias, and it can drape smoothly around curves instead of hanging like a flat panel. Grain line is the hidden compass of sewing. A pattern piece usually marks the grain line so the maker can align it with the fabric threads, helping the finished garment hang correctly. If the grain is off, a piece can twist or ripple even when the stitching is neat. Seam allowance is the extra fabric beyond the stitching line, and it gives the seam room to hold together. Pressing seams as you sew can make a project look much cleaner because heat and pressure help the fabric remember its new shape. Sewing is not just stitching, it is also shaping. Darts remove a wedge of fabric so a flat piece can curve around a body or form. Pleats fold extra fabric into controlled fullness, which can add movement while keeping the top edge tidy. Gathers pull fabric into many small folds, spreading fullness in a softer way. Tucks are stitched folds that can be decorative, structural, or both. A hem is the finished edge that keeps fabric from looking raw, and a rolled hem turns a tiny edge under twice for a narrow, neat finish. A French seam encloses the raw edges inside the seam itself, making the inside of a garment look almost as tidy as the outside. A flat-felled seam folds and stitches the seam allowance down, creating a durable, clean finish, often seen in sturdy casual clothing. Pinking shears cut a zigzag edge that helps reduce fraying by shortening the loose threads along the edge. Serges trim and wrap the edge with thread in one pass, creating the stretchy looped finish seen inside many modern garments. Buttonholes are small engineering moments too. A good buttonhole is reinforced with stitching so the slit can open without the fabric unraveling. Buttons work because a raised disc, knob, or shape passes through that reinforced opening and then sits crosswise to hold the layers together. Snaps do the same job with two interlocking pieces that press together. Hook and loop fasteners use tiny hooks on one side and fuzzy loops on the other, making a closure that can be opened and closed again and again. Zippers are even more satisfying once you picture the teeth. The slider guides two rows of teeth together at the right angle so they interlock, then separates them again when it moves the other direction. The small tab you pull is called a puller, and the little box at the bottom of many separating zippers helps align the two sides before the slider starts its climb. Drawstrings are simpler but clever. They gather fabric through a channel, letting one piece adjust to different sizes by tightening or loosening a cord. Elastic does the adjusting by stretching and recovering, and its usefulness depends on returning close to its original length after tension is released. Fabric weight is often measured in GSM, or grams per square meter, which describes how heavy a fabric is for a standard area. A higher GSM usually feels thicker or heavier, though weave, fibre and finish all influence the final hand. The word hand in textiles means the way a fabric feels and behaves when touched, including softness, stiffness, drape, and texture. Drape is how fabric falls under its own weight, and it can turn the same pattern into something crisp, flowing, structured, or relaxed. Interfacing adds hidden support to areas like collars, cuffs, waistbands, and button plackets. Some interfacing is sewn in, while fusible interfacing has adhesive that bonds with heat. The goal is not to make the whole garment stiff, it is to give certain areas just enough backbone. Lining adds a second layer inside a garment, making it easier to slip on, hiding inner construction, and sometimes improving the way the outer fabric hangs. Underlining is different because it is attached to the main fabric pieces and treated as one layer during construction. Tailor's chalk, washable markers, and tracing wheels help transfer temporary guidelines to fabric. Those marks are quiet helpers meant to disappear after they have done their job. Pins hold layers together, but clips can be kinder to materials that should not be pierced. A thimble protects a fingertip when hand sewing, especially when pushing a needle through firm fabric. Needles themselves vary more than people expect. A ballpoint needle slips between knit loops rather than piercing them sharply, while a sharp needle is better for many woven fabrics. A denim needle is sturdier, and a universal needle is a general-purpose compromise. Thread has its own structure, often made from fibres twisted together to create strength and smoothness. Embroidery floss is commonly divisible into strands, so a stitcher can choose a thicker or finer line by changing how many strands are used. Satin stitch fills a shape with smooth parallel stitches, while backstitch creates a steady outline. Chain stitch makes linked loops that look like a tiny cord laid on the surface. Cross stitch uses X-shaped stitches on an even grid, turning fabric into a pixel-like canvas long before digital pixels entered the chat. Needlepoint is usually worked on a stiff open canvas and the stitches cover the surface like a soft mosaic. Applique attaches one piece of fabric on top of another, allowing shapes, letters and patches to be added without weaving a new cloth from scratch. Quilting joins layers together with stitching, a top layer, a middle batting and a backing. The quilting stitches can be plain lines, decorative curves, or dense textures that change the feel of the whole piece. Patchwork uses smaller fabric pieces to build a larger design, and repeating blocks can create stars, stripes, diamonds, or abstract patterns with just a few shapes. The log cabin quilt block is built around a center square with strips added around it, making a design that grows outward step by step. Textile patterns often have repeats, and a repeat is the distance before the design starts over. Matching a large print across seams takes extra fabric and careful cutting because the maker is not just sewing pieces together. They are continuing a picture. Plaid matching is a classic example since horizontal and vertical lines reveal even small shifts. Stripes can play tricks too. Vertical stripes can emphasize length, horizontal stripes can emphasize width, and diagonal stripes can add a feeling of movement. Nap is another subtle textile feature. Fabric with nap, like velvet or corduroy, looks different depending on the direction the fibers lean. Cut one piece upside down compared with another, and the same fabric can seem like two slightly different colors. Corduroy is measured by wales, the raised ridges running along the fabric. Fewer wales per inch means wider ridges, while more wales means a finer texture. Terry cloth uses loops on the surface to increase absorbency and softness. Fleece is brushed to raise fibers into a fluffy surface that traps warm air. Microfiber is made from extremely fine synthetic fibers, and the huge surface area of those tiny fibers can make the material feel soft and pick up dust effectively. Non-woven fabrics are not woven or knitted. They are made by bonding fibers together through heat, pressure, adhesives, or tangling. Felt is a familiar non-woven example, with fibers matted together into a dense sheet. Labels inside garments carry their own compact language. Care symbols can show washing, drying, ironing, and bleaching instructions without needing a long sentence in every language. A tub shape refers to washing, a square often relates to drying, a triangle relates to bleaching, and a little iron symbol is exactly what it looks like. The symbols are small, but they help a fabric survive normal use with less guesswork. Thread count gets mentioned often, especially for sheets, but it is not the only measure of quality. Fiber length, weave, finish, and feel all matter, so a higher number is not automatically better. The best textile facts tend to work that way. One number helps, but the whole story lives in the structure. From warp and weft to zippers and hems, fabric is a soft machine made from repeated choices. Every stitch, loop, fold, and fastener is a tiny answer to the same friendly question. How do we make something flexible, useful, comfortable, and nice to look at all at once? This next fact can begin with paper, because paper is one of those quiet inventions that feels ordinary only because it works so well. A sheet of paper is made from fibers that have been spread into a thin mat, pressed and dried, leaving a surface that can bend, fold, hold ink, and travel easily from one desk to another. The direction those fibers settle is called grain direction, and it affects how the sheet folds and curls. Fold paper with the grain, and it usually bends more smoothly. Fold against the grain, and the crease may feel stiffer or less tidy. That grain fact leads naturally to bookbinding, where the direction of the paper matters because pages need to turn comfortably. Even a simple notebook is a small piece of engineering. The cover protects, the spine holds, the pages flex, and the binding decides whether the notebook lies flat or springs closed. A saddle-stitched booklet is held with staples through the fold. Perfect binding uses adhesive along the spine, which is common for many paperbacks and catalogs. Spiral binding uses a coil through punched holes, letting pages flip all the way around. Case binding, often used for hardcover books, attaches page sections into a sturdier cover. The page sections in many bound books are called signatures, and they are formed when larger sheets are folded into groups before trimming. That means a book page may begin life as part of a much larger printed sheet, arranged so everything lands in order after folding. This arrangement is called imposition, and it is one of those print shop ideas that feels like a puzzle hiding behind the finished object. Margins are another quiet design choice. They give thumbs a place to hold, give the eye a little breathing room, and keep words from falling too close to the edge. The inner margin near the spine is called the gutter, and it often needs extra space because the curve of the binding can swallow part of the page. Line spacing, or leading, helps text feel airy or dense. The word leading comes from the strips of lead once used between lines of metal type. Kerning adjusts the space between specific pairs of letters, while tracking adjusts spacing across a wider run of text. Good spacing is often invisible. You notice it most when it feels wrong. Fonts carry personality before a sentence even starts. A monospaced font gives every character the same width, which is why it feels tidy for code, forms, and old typewriter styles. Proportional fonts give narrow letters less room and wide letters more room, making ordinary reading feel smoother. Typewriters used mechanical arms or elements to strike ink through a ribbon onto paper. The ribbon was the middle layer, carrying ink so the letter form could transfer with pressure. Correction tape and correction fluid became little office superheroes because they let people cover a mark and keep going without starting over. Carbon paper solved a different problem by making copies as someone typed or wrote. Pressure on the top sheet transferred pigment from the carbon layer to the sheet below, creating duplicates before everyday photocopying was easy. Photocopiers work through light and static electricity, using charged areas to attract toner and transfer an image to paper. Toner is a fine powder, not liquid ink, and heat helps fuse it to the page. Inkjet printers spray tiny droplets of liquid ink, while laser printers use toner, which is why the two can behave differently on different papers. Paper weight can be described in pounds or grams per square metre, and the systems do not always compare neatly because the pound system depends on the basis size of a paper type. GSM is more direct because it measures the weight of 1 square metre. Paper finish matters too. Coated paper has a smoother surface that can make images look crisp and colours feel rich, while uncoated paper often feels softer and more absorbent. Newsprint is lightweight and absorbent, which is part of why it has a distinct texture. Cardstock is heavier and stiffer, making it useful for cards, covers, tags, and signs. Vellum can mean different things depending on context, but in modern stationery, it often refers to a translucent paper with a soft, cloudy look. Tracing paper is translucent too, allowing someone to see a guide underneath while drawing. Graph paper adds a printed grid, turning blank space into measured space. Isometric paper uses angled grid lines that help sketch three-dimensional looking shapes. Dot grid paper offers a quieter guide with points instead of full lines. Ruled paper guides handwriting, and wide-ruled, college-ruled, and narrow-ruled pages simply use different line spacing. A margin line on notebook paper is not just decoration. It gives notes a left boundary, a place for numbering, or a spot for small reminders. Sticky notes use a pressure-sensitive adhesive that holds lightly and can be removed without acting like permanent glue. The adhesive is placed along one edge so the note can lift and re-stick, making it perfect for temporary thoughts. Envelopes are folded paper containers with flaps arranged to hold a message flat. A security envelope may have a printed pattern inside, so the contents are harder to read through the paper. Window envelopes align an opening with an address printed on the sheet inside, saving an extra label. Paper clips hold sheets by spring tension, and their familiar looped shape spreads pressure without needing a hole. Binder clips use folded steel arms to open a clamp, and when the arms fold down, the stack sits flatter. Staples fasten by piercing sheets and folding the metal legs on the other side. A staple remover lifts those folded legs so the paper can separate with less tearing. Hole punches remove small circles so pages can fit into rings, brads, or folders. A 3-ring binder works because pages can be added, removed, and rearranged without changing the whole stack. Tabs turn a stack into sections, and color-coded tabs add another layer of quick scanning. Dividers, labels, folders, and binders all show the same basic idea. Paper becomes more useful when its order is visible. The same is true for planners. A monthly view gives the big shape, a weekly view gives rhythm, and a daily view gives detail. Checkboxes are tiny agreements with the future. They turn a task into something that can be noticed, done, and marked complete. Bullet journals use a simple key of dots, circles, dashes, and marks so notes, events, and tasks can live in one flexible system. The system works because it is structured enough to guide you and loose enough to adapt. Pens bring their own tiny mechanics. A ballpoint pen has a small rotating ball at the tip that picks up oil-based ink from the reservoir and rolls it onto the page. A rollerball uses water-based ink, which often feels smoother but may dry more slowly. A gel pen uses pigment suspended in a gel, allowing bright colors, opaque marks, and a gliding feel. Fountain pens use capillary action to draw ink through a feed to the nib. The nib tines spread slightly with pressure, and the shape of the nib can change the character of the line. A broad nib makes a wider stroke, while a fine nib keeps writing compact. Felt tip pens use a porous tip that carries ink to the surface, and brush pens use flexible tips for thick to thin lines. Highlighters use transparent fluorescent ink so text remains readable while the highlighted section seems to glow. Pencils are not filled with lead. The writing core is usually graphite mixed with clay. More clay makes a harder, lighter mark, while more graphite makes a softer, darker mark. That is why pencil grades range from H for harder marks to B for blacker, softer marks, with HB sitting near the middle. Erasers work by gripping graphite particles and lifting them from the paper. A kneaded eraser can be shaped, pressed, and folded to pick up marks gently, especially in drawing. A ruler looks simple, but it is a measurement agreement printed on a straight edge. The zero mark matters because starting at the worn end of a ruler can make measurements less accurate if the edge is damaged. A metal ruler protects the edge better for cutting, while a clear ruler lets the maker see the work underneath. Scissors cut because two sharpened edges pass closely against each other, shearing the material between them. Craft knives use a single sharp edge and a cutting mat to protect the table. Cutting mats often have printed grids and are made to heal small cuts enough that the surface stays usable. Glue sticks spread a solid adhesive in a thin layer, while liquid glue can soak into porous materials before drying. Double-sided tape hides the adhesive between layers, keeping a project looking clean. Washi tape is decorative paper tape that can usually be repositioned more easily than standard tape, which makes it friendly for planners, labels, and crafts. Stamps transfer ink from a raised design to a surface, and self-inking stamps tuck the ink pad into the mechanism. Embossing raises a design into paper by pressing it between shaped surfaces. Debossing presses the design downward instead. Foil stamping uses heat and pressure to transfer a shiny film onto paper, adding a metallic accent that catches light as the page moves. Letterpress printing presses inked raised type or plates into paper, often leaving a subtle impression you can feel. Screen printing pushes ink through open areas of a mesh stencil, which works on paper, fabric, and many flat surfaces. Risograph printing uses stencil-like masters and vibrant spot colors, giving prints a distinctive layered look. Stationery facts have a charming way of stacking up. Fiber becomes paper. Paper becomes pages. Pages become notebooks. Notebooks collect ink. Ink becomes plans. And plans become little anchors for the day. That is why a clean sheet of paper still feels hopeful. Thanks so much for spending a little time with Junk Drawer Facts. I hope this gave your brain something fun, light, and curious to wander through. If you enjoyed listening, liking the video, and subscribing to the channel really helps encourage me to keep making more of these cozy, fact-filled episodes. Until next time, stay curious.